So separation of variables, solving ODEs, ordinary differential equations. This is actually what we started the chapter with, was differential equations and solving differential equations. Those were all really easy to do. Now we're stepping it up a notch because, well, we've done some other work with solving integrals and stuff like that. Things are more complicated. But if you follow these steps, you will be just fine. Okay? And you must follow these steps. You cannot do them without these steps. You can't do them. First one, separate the variables. Y, dy on one side, x's and dx's on the other side. Okay, put all your y's and dy's on one side, all your x's and dx's on the other side. Integrate. Integrate both sides. Antiderivative of both sides. Plus c. You must add the plus c. Solve for c using the initial condition. Plug in x and y. What's c? When x is this and y is that, what's c? You got to solve for c. And then once you figure that out, put that number in for c, solve the equation for y. Because it may not be y equals, when you do the antiderivatives, it may not be y equals. You may have to go in and do the y equals part. Okay? Questions? All right. Let's do this. Consider the differential equation dy dx equals 3y. Find the solution for y equals f of x to the differential equation, satisfying f of 0 is 1. So when x is 0, y is 1. That's what that means. Okay. So I have my differential equation, dy dx equals 3y. dy is on one side, dx is on the other. So I multiply both sides by dx, divide both sides by 3y. Or I should say times 1 over 3y. And you'll see why in a minute. And then times dx times dx. By the way, there are some people that have absolute heart attacks about multiplying by dx, because dx isn't actually a value. But for this purpose, we can do it. Who cares? So I get 1 over 3y dy is equal to dx. Separated the variables. Okay. Now, in order to facilitate, I'm going to take the 1 over 3y and rewrite that as 1/3 1 over y dy. And you will understand why. Actually, let's back up here. Just cross out what you've done. Almost. Trust me. Trust me on this one. Trust me on this. It's a little. What? Okay. This and that. And I'm just going to start all. Hang on. Chill. 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 dy dx equals 3y. Trust me. Trust me. I am an expert. I know what I'm doing. Usually. Do try this at home. Okay. So, let me back up. And you'll kind of understand why a little bit. So, instead of moving the 3y over, just move the y. Divide both sides by y. Or I should say 1 over y. And then multiply both sides by dx. And you get 1 over y dy is equal to 3 dx. What's my next step? I did the first step, separate the variables. What's my second step? Integrate both sides. Integrate, integrate. What is the integral of 1 over y dy? natural log of y, and I'm going to put the absolute value bars on there for now. The antiderivative of 3dx, 3x. And when I integrate both sides, what else do I need to have? Plus c. Do not forget your plus c. You must have that plus c. Okay. My next step. Solve for c using my initial condition. Go back up here to my initial condition. When x is 0, y is 1. So off to the side over here, the natural log of 1 equals 3 times 0 plus c. Well, what is the natural log of 1? 0. You better know that. It's one of those things you absolutely need to have committed to memory. Absolutely need to have committed to memory. You have until May, oh, I don't know, what? 15th. Ooh, good for you. Okay. So c equals 0. That's really nice. Okay. Because that makes it, I plug in 0, that means the natural log of y is equal to 3x. Now, what's my last step? Solve for y. Now, we solve for c. C is 0, so it's gone. If I had a number there, I'd still have to do that. Solve for y. How do I get rid of the natural log? What? Yeah, raise both sides to the e power. E to the ln of y, e to the x. What is e to the ln of y? Y equals e to the 3x. Okay. Yeah. Yep. Just leave it like that. Now, we can leave it like, part of the reason, yeah, you're done, you can leave it like this. Now, a couple of notes. Our initial condition, y was positive. So once I understood that y was positive 1, when x was 0, y gave me positive 1. I know that my domain, my y's were always going to be positive. I didn't have to worry about the absolute value anymore. I didn't have to worry about negative y's and such. You do have to sometimes be careful. These are fairly straightforward on here. Part B, what is the domain and range of the function found in part A? So in my final answer here, what is my domain? What values of x am I allowed to have? Anything, right? I'm allowed to have any number as an exponent. All real numbers. My range, on the other hand, is a little limited. E times itself will never be 0 or negative. My range, y, is greater than 0. And there's a difference between being positive and being non-negative. Y is positive here. It's not non-negative. Understand the difference between the two. There's a difference between the statements positive and non-negative. Bingo. Non-negative includes 0. Positive does not. You got to watch that. Okay, this will never be 0. It will never be negative. Okay, yeah, you gotta pay attention. Those are important statements. They're important to understand the difference between them. You with me so far? Okay. Follow the step-by-step process. It's not horrid. Okay. So consider the differential equation dy dx equals 1 plus y over x. Find the general solution to the differential equation above. General solution means that we do not have an initial condition, so we're not going to solve for c, but you better have that c as part of your answer then. So our first step is still separate the variables. Move the y's to one side, move the dx's to the other side. So to do that, I get 1 over 1 plus y dy equals 1 over x dx. You see where I got that from. Multiply both sides by 1 plus y. I can't just multiply by y because it's 1 plus y. I can't separate the y from the 1 because there's addition, not multiplication. Previous one, I could separate the y into 3 because it's multiplication. I can't do the separation on the addition part. Okay. So what is the antiderivative? Now I need to integrate both sides because we're into this and it's great. Okay. So what is the integral of 1 over 1 plus y dy? Yeah, the natural log of 1 plus y. The integral of 1 over x, ln of x, plus c. Ooh, good. Put the plus c in when you take the antiderivative. Immediately at that point, do that. Generally speaking, this would also be the point before going any farther where you would solve for c if you're solving for c. Okay? Some people like to simplify things first and then solve for c. I'm a strong believer, and this is mostly because it's what AP does. Plug in your x and y values now to solve for c rather than after you've solved for y. Okay, do it at this point if you're doing it. We're not here, obviously, but this would be the time to do that, just like in the previous one. However, we do need to solve this for y. So how do we get rid of the natural log? E. So e on this side and e on this side, and remember the entire thing is being raised to the e power, or is my power. So this one's easy. I get 1 plus y. The other side, I get I can't just bring that whole thing down. What's being raised to the natural log? Or what am I taking the natural log of? Only x, not the c. So before I do this, I have to understand my rules of exponents. Know that, hey, this is e to the natural log of x times e to the c. Because what do we do when we multiply two things at the same base? We add the exponents. So I can make them two things instead. So I get e to the natural log of x, which gives me x. And I should technically have the absolute values on here because I don't know whether they're positives or negatives. Times e to the c. Times e to the c. Yes? Because these are two separate things, because I cannot take e to the natural log, e with the natural log of x plus c power. Only the natural log part comes down. The plus c is not part of my logarithm. So only the x, e to the ln of x is x. E to the ln of x plus something else is not x plus something else, and that is also part of my logarithm. The c is not part of my logarithm. Okay, so what do? I rewrite this as 2 powers of e. Okay, so that's what I need to do. Now, this is where things get a little kind of odd and goofy. We have e to a constant. Okay, what is e to a constant value? It's just a constant value. We don't like to write e to a constant unless we know what that constant specifically is, right? E squared, e cubed, whatever. I believe it is e squared, e cubed, whatever, right? I don't know what c is. C is any number. So e to the c power is any number. I don't like that. That's ugly looking. That's not pretty. So replace e to the c with a, because e to the c is just some number. So if I don't know what that numerical value is, I can call it whatever I want. And that's a lot prettier. A is a lot prettier than e to the c. Right? The absolute value, I hear somebody saying, oh my God, the absolute value, what do you do, what do you do, what do you do? Okay, yeah, I know. Inside your internal voice was doing that, right? Not you were doing it out. Your internal voice is going, oh my God, I'm so confused, what am I going to do? Okay. We don't know what our initial value is. We don't know what we're dealing with. At this point, we can't hold on to that absolute value forever. We have to make an assumption that we can go and split it. We can assume that this is a reasonable general solution. Knowing that some things might end up being positives or negative changes as we go along. We can't do any better than this. This is where we want to go with it. Okay. If we have a specific values of y or c, then we need to worry about that, or x and y. To find c, we may need to worry more about absolute values at that time. So, for example, in the previous problem, if the point had been 0, -1, we would have had to make sure we had the absolute value of -1 in there, and then adjust our final answer appropriately. Okay. Questions?
So, does it have to be subscript?
No, you can put any other value. Well, you can put any other you want. A is the typical one, like C is the typical one. C for your constant. If you're doing more than one antiderivative, and let's say you're doing a polynomial and you're doing the first antiderivative and then the second antiderivative and so on. So the first one you do plus C. Well, the antiderivative of C is Cx, and then you'd have to add another constant, so you usually put D, and so on. I've done that a couple of times. There's things that'll happen if you're doing a second and third antiderivative. You just work your way back up and you work your way through the alphabet however you feel comfortable. Okay. C is typically your standard plus C. A is the standard. If you have E to the C, it's standard to replace it with A. But any constant would work, technically. I'd kind of stick with the standards, though, just so nobody gets confused at what you're doing when somebody else other than your teacher is reading it. Okay. Question number 3. Tell you what, why don't you guys give this one a shot? Okay, that's enough whining and crying. Weeping silently to yourself that, oh my God, I don't understand this at all. Yes, I'm making fun of you. Get over it. Okay, so step number 1, separate the variables. Y dy, x dx. So that means you get e to the 2y dy is equal to 3x squared dx. Integrate both sides. The integral of e to the 2y is 1/2 e to the 2y, because the integral and derivative of e to some power is e to that power. And then because I'm doing the antiderivative, I need to counteract what the derivative of that power is. That's where the 1/2 in front comes from. Equals the antiderivative of 3x squared is easy. That's x cubed plus c. Plug in 0 for x and 1/2 for y. One half e to the 2 to the 1/2 equals 0 plus c. Okay. So what is c? 1/2 e. So that means I take this, so I have 1/2 e to the 2y equals x cubed plus 1/2 e. Are you ready for some fun? Okay, now I need to solve for y. Excuse me. Okay, you with me so far? Now, I can't do the natural log of both sides because I don't have e by itself. I don't have e to some power. So taking the natural log at this point doesn't do me any good. Multiply everything by 2 to get rid of the 1/2 in front of the e. E to the 2y equals 2x cubed plus e. Now you take the natural log of both sides. I get 2y equals the natural log of 2 to the x cubed plus e equals natural log of 2x cubed plus e, right? That's what I have. So, but what does, when I have addition, I can't distribute the natural log across addition. So it's the whole thing. Okay. So you got to watch that because that's what you wanted to do, right? Distribute the natural log. You can't. Because the rules of logarithms do not distribute across additions. You can take things that are multiplied and make them the natural log of things added. Okay? But just like you can't, if you have the sign of x plus 3, that's not the sign of x plus the sign of 3. You can't distribute a function. So this is the natural log of 2x squared plus e. Divide everything by 2. 2x cubed, thank you, 2x cubed. So I get y equals the natural log of 2x cubed plus e all over 2. And that's a little forced together there. Let me make all over 2. Find the domain and range. What's my domain? I have a limit on my domain. Okay. I cannot take the natural log of a non-positive number. So that means 2x cubed plus e must be greater than 0. Okay. Must be greater than 0, cannot be equal to 0, must be larger than 0. Subtract e from both sides, 2x cubed is greater than negative e, divide both sides by 2. X cubed is greater than negative e over 2. Cube root both sides, and cube rooting both sides, I don't have to worry about flipping my inequality or anything because cube roots and cubes, if the originals are negative, so is the roots and all that good crap. So I get x is greater than the cube root of negative e over 2. That is my domain. And my range is y is greater than 0. Actually, no. My range will be, no, my range is actually everything. Because logarithms, yeah, it's e, it's the logarithms. My range is all real numbers. Y's can be anything. Okay. My domain are all my possible inputs, right? What can x not be or what can x be? Sometimes it's easier to figure out what it can't be than what it can be. X, in this case, whatever value of x has, this has to be positive. Okay? I cannot take the natural log of a negative number. I cannot take the natural log of 0. Because what is the natural log? It's the inverse of e to some power. And e to some power would never be 0, and never be negative, so I cannot do the inverse of that. Okay? So This has to be greater than 0. So I set whatever's inside the log greater than 0 when I solve that. Basic algebra. Okay. That gives me my domain. My range are all the possible outputs. Well, with natural logs and exponentials, you kind of have to understand what they are and what they look like. So if I go back, okay, e to the x, and then the inverse function, ln of x. Running out of room. There we go. Okay. Remember, functions are reflected across the line y equals x. Okay? So my domain and range of 1, my domain of e to the x is the range of the natural log, and vice versa. So my range of e to the x is all real numbers. Or so my domain, I can take the domain, I can take, e to the x can be, I can put anything for x. So my domain for this is all real numbers, which means the range for this is all real numbers. My range on this one must be greater than 0, which means my domain for this one is greater than 0. That's how inverse functions work. And you have to have an understanding of what these things look like by their graphs, if nothing else. A picture will tell you an awful lot about domain and range. If you know what exponentials look like, it tells you an awful lot about their domain and range. If you know what logarithms look like, it tells you an awful lot about domain and range. But these are things that you need to understand and know. And don't worry, we'll work a lot more with them as we progress on. Okay. Remember, you have until, what is it, March 15th or May 15th? That's quite a ways away. It's like a month and a half, 2 months and a half. Or, 2.5 months. Plenty of time to get this stuff down. Okay. Sample number 4. Solve for the initial value problem. Got an issue with this one. You can't add or subtract to separate the y's and x's. I can't add 2y to both sides because that's 2y plus dy, which is not an integrable thing. So, factor first. Factor first before doing your separation of variables. So, your first step, factor. dy dx equals -2 times y plus 3. Now I can separate the variables. 1 over y plus 3 is equal to y plus 3 dy equals -2 dx. Integrate both sides. Okay. 1 over, hang on. Okay, natural log of the absolute value of y plus 3 equals -2 x plus c. What are my initial conditions? When x is 1, y is -10. Okay. So this is one where solving for the initial condition at this point can be a pain in the butt. It can be done. There are times when it's easier to solve for y first, and then plug in the values to figure out what c is. Okay, sometimes it's easier to do that and figure it out at that point what it is. This is one of those times. Trying to solve for c at this point, putting in -10, natural log of 7, it's an ugly looking thing. And this is typically a non-calculator question. If you get this question on the AP test, this would be non-calculator. Now, I don't know if they would necessarily go this far with it, but these are always always in non-calculator portions of the AP test. Okay, so what you would need to do here is, I'm not going to worry about the limit stuff. So we're not even going to worry about that. Okay, is I would actually go ahead and solve for Y first, and then plug in the values to figure out what C is. It's not as nasty as it sounds. It is doable in several places. It's either immediately or after you solve for Y. With the natural log of Y plus 3 and negative 10 being my initial Y value, you kind of want to mess around a little bit first. So my first thing is that, raising both to the E power. So I get Y plus 3 equals E to the negative 2x times E to the C. Call E to the C A. Y plus 3 equals A E to the negative 2x. And then subtract 3 from both sides. Y equals A E to the negative 2x minus 3. And then once again, what was our initial condition? When x is 10, when x is 1, y is negative 10. Plug in 1. Okay, it's not really a simple thing. Might actually be even easier to plug in negative 10 and 1 here. Okay, so I'll do this, go back to here, this one here. Let's do this. And solve for A at this point. So if I plug in 1, plug in negative 10. Negative 10 plus 3 equals A E to the negative 2. Negative 7 equals A E to the negative 2. Divide both sides by E to the negative 2, and you're going to love this one. Those cancel. What is negative 7 over E to the negative 2? Negative 7E squared. So that's what A is. So I go back to here, Y plus 3 equals negative 7 E squared times E to the negative 2 x, which means Y equals negative 7 E to the 2 minus 2x minus 3. And if you stop and think about it, plug in your initial value, does this make sense? If I plug in 1 for x, will I get negative 10 for y? Double check yourself, make sure this is a valid solution. If I put 1 in here, I get 2 minus 2, which is 0. What's e to the 0? 1. So I get negative 7 minus 3 gives me negative 10. This one works. Double check yourself when you get to the end to make sure you've got a valid answer. It's not as bad as it gets, really. Kind of. It's not a pretty one. Questions? Yes. Okay, what are rules of exponents? If I have a negative exponent, how do I get rid of it? If it's in the denominator, move it to the numerator, make positive. If it's in the numerator, move it to the denominator, make positive, right? You got it? You need to be able to work that around, because that will happen to you on the test. That'll be a multiple choice answer. Might have some goofy crap like that happening to you on a multiple choice. And you've got to recognize that 1 over e to the negative 2 is e squared. Okay. Other questions on this one? Okay. So why is this so important? Okay. Please note, this is a scoring rubric for a portion of an AP question last year, actually not last year, but the year before, that required solving an ODE with a given initial condition. You get 1 point for separating the variables, putting y's and dy's and x's and dx's. You get 1 point for doing that. You get 2 points for the antiderivatives, 1 for each antiderivative, 1 for the dy's, 1 for the dx's. You get 1 point for Constant of integration. 1 point for plus C. And plugging in the initial value. If you, on this one here, if you plug in, you get 1 point for plus C, and you get 1 point for using the X and the Y values that they give you. Even if you get the wrong C, if you do your calculation solving for C incorrectly, but you put plus C and you plug in X and you plug in Y, you get the point for using the plus C and using the initial condition. If you screw up with your arithmetic or your algebra and you get C is supposed to be -4 and you end up getting +4 because you screwed up on a negative positive somewhere, you won't be able to get the solve for Y part, but you'll get that you add plus C. You get a point for, literally get a point for putting plus C and plugging in X and Y in what you got. In what you got. As long as the integral is a reasonable integral. Even if the integral's wrong, but it's a reasonably incorrect integral. It will give you the point for plugging the values in. Okay? So that's 5 out of 9 possible points on the question. Often these are 6, sometimes these are 4. I've seen this split up into 2 points here. I've seen this made 1 point for the antiderivatives. It kind of depends upon what the rest of the question is. This question would probably include a slope field where you have to make a slope field for the differential equation. That's usually 1, maybe 2 point stops, but usually only 1 point for that. And then you'd get another point for what's the domain and range, or use this to estimate, or some weird goofy thing. Okay. But notice what they have down here. Maximum of 3 points if no plus C. You don't put plus C, the best you can do, the absolute best you can do is 3 points. 1 for the separation, 1 for each antiderivative. If you get those 3 things correct and forget your plus C, it matters not if you solve for Y. It matters not if you plug in the X and Y because you don't have any C to solve for at that point. Somewhere you have to have plus C. If you don't have that plus C, you can't get, the best you can do is 3 out of 5. The best you can do is 3 out of 5. Note, you get nothing if you don't separate the variables. If you don't put Y's dy's and X's dx's, doesn't matter what you do after that point, it's moot. They don't even look. You don't do that first step right, nothing else matters. Nothing else matters. You don't do that first step right. You can put plus C all you want. They're not going to give you points for the plus C because you didn't separate the variables. Okay. I have graded, and depending upon how much time we have, how things work out, we will do an AP test in here. And you will be able to compute your AP score. Now, we can't do it all in one sitting. We don't have 3.5 hours together. So we can't do it all in one sitting. And I've done this, and I've graded it. And I've had several students that screwed this part up and didn't get anything after that. This is one of those questions that I think is relatively simple to get at least a few points on. At least a few points on. You may not necessarily get all of them depending on how difficult the problem is, but there's at least a few points to be had. Part of the reason why I point it out here. I'm going to tell you, you're going to have to do this on your chapter test next week. I'm going to grade it real close to that. The closer we get to the end, the more AP-like I am on my grading. The more strict I am, the less partial credit you get. There are specific things that I will be looking for. I will look for on an ODE, solve the ODE. I will look for, did you separate the variables? Did you do the antiderivatives? Did you put plus C? Did you plug in the initial condition? Did you solve for Y? And I'll be looking for it. So I'd probably be 6 and then add a couple more for trying, because I'm not that mean. Yeah, AP does not get points for trying. You specifically have to get things specifically correct. You do not get points for trying. Although sometimes it seems that way depending upon the rubric. Yes, good question. My practice? No. Ones I've given out of 108 possible points, I think the best I've ever had is somewhere in the 70s.
Oh, great. That's what I like to hear.
I imagine that there have been people, and I'll go ahead and stop.